Okay, this is a question on a series. I think the most difficult part is this part B, and okay, of this part is a bit this part is also a bit challenging. I'll just do this part first. So, part one is in terms of n, where Sn equals to this one. So we recognize that this part is quite similar to this part, except that this is a fourth. This number, this part, right, is 4 times of this. So what I do is I just take Sn equals to this thing. So part 1, right, this thing is just equals to 4 summation r equals to 1. If I take a minus 4 instead, so I multiply a minus 4 instead, then this part would become just 1 minus r. I put a minus 4 so that this one will be 1 minus r, and this would be similar to 1 minus here. So then I will be able to use the results there. And this is actually after this, okay, I have a minus 4 multiplied by summation r equals to 1 n. So this part is just this part equals to this part. So I'll change this to, okay, just a change in I can also make all this r, and this would all be r, so it's actually the same. So this part would be just equals to 1 over r plus 1, and minus 3 over r plus 2 plus 2 over r plus 3. So this part, and to solve this part, I will use the method of difference. So minus 4 multiply to the whole thing. Okay, what is inside this? So when r equals to 1, this is just half, correct? Minus 3 over 3 plus 2 over 4. Okay, so plus when r equals to 2, I'm writing out in these lines because then it's easier to use the method of difference. So when r equals to 2, this is 1/3 minus r equals to 2 is 3/4, and this is r equals to 2 is 2/5, so plus 2/5. And when I goes to r equals to 3, I'll get plus 1/4. Okay, then minus 3/5 and plus 3 the third term, so 2 plus 2 over 6. Okay, and if I continue to here, so I will add another one thing called let's say the fourth term. I go to the fourth term. Actually, you can stop as and when you catch the pattern. So minus 3 over 6, and the last one was 4 plus 2 over 7. So you realize that, okay, 2 over 4 plus 1 over 4 will give me 3/4. 3/4 minus 3/4 will just cancel away. So 2/5 plus 1/5 is 3/5. 3/5 and minus 3/5 would just cancel away, and I suspend 2 over 6, and then there will be another term here which cancel away and cancel away. So that means if I'm left with a triangle, okay, these 3 terms over here, and the last 3 terms would be, then I expect there will be 3 terms here if you add a dot dot dot. Okay, so these are in between, and then there will be 3 terms over here. So then I insert my n minus 1, that means the second last term into here. I would have how about this? I just take this out first. So n minus 2, if I substitute inside, no, n minus 1 term, if I substitute inside, I'll get 1 over n minus 3. n minus 1 plus 2 is m plus 1 plus 2 times m minus 1 plus 3 is m plus 2. Okay, then the last term is of course 1 over m plus 1 minus 3 over m plus 2 plus 2 over m plus 3. I could just get this term out as well to prove that actually in fact, so this last term is that when m minus 2, so this would be 2 m minus 2 plus 3 is just m plus 1. So 2 m plus 1 plus 1 m plus 1 is 3 m plus 1 minus 3. So this term would cancel away. So this would cancel away. So based on the pattern earlier, I know that they would cancel away. So that means now. So I must not forget that minus 4 multiplies to the entire thing. So then here half minus 1 is just half minus 1 is just minus half. Minus half plus 1/3 would give me, okay, using the calculator, I'll take half minus 1 plus 1 divided by 3 equals to, then math and change to fraction, minus 1 over 6. So minus 1 over 6 is the top part, and then here we have minus 3 over m plus 2 plus 2 over m plus 2, so minus 1 over m plus 2, okay, plus the last term 2 over m plus 3. I hope I'm correct, I didn't make any mistake, right? So but where did, okay, can, this is alright. So we have it here equals to 4 over 6, which is just 2/3, okay, then plus just make sure it's really, okay, be very careful with working, so especially when you just want to make one mistake and you get the answer wrong. So 4 over m plus 2 minus 8 over m plus 3. So we have this, okay. So I will just write this answer over here. I'll just erase everything and then write that answer over here. Okay, so now that you got the working, okay, using method of difference mainly and using the earlier result, so equals to 2/3 plus 4 over m plus 2 minus 8 over m plus 3 is my answer for this question. Okay, so I erase it to make space for my other workings, okay, other parts of this question. So this second part is easy. So when it says hence find s approaches infinity, when s approaches infinity, this n is replaced with infinity. So you say when n approaches infinity, the question is when n approaches infinity, 4 over m plus 2 approaches 0, 8 minus 8 over m plus 3 approaches 0. Therefore, s infinity is just equals to 2/3. Okay, because of this. So I got the answer here, so I will just write 2/3 as the answer here. Okay, so then I will be, this is the answer, so I will just leave it first. So using the result to part 1, now we are asked to find this. Okay, then we must try to change this to a form that is likened to this in order to use the result. This is 4r, this is 4r, then this is r plus 2, this is r plus 1, r plus 3, and r plus 2. So I suspect by replacing this with r minus 1, I will get to here. So what I do is I'll take n summation r equals to 1 4r over r plus 2, r plus 3, r plus 4 equals to what? So I recognize that the first term for this is 0. So I must make sure that this one gets, what is this? If I'm going to use this expression here, 4r minus 4, r plus 1, r plus 2, and r plus 3, what should be my number here? Okay, the first term here is 4. So in order for me to get a 4, my r must be equals to 2. So let's check the other. R equals to what? This is first term 3, yes. 4, 2 plus 2, 4 also. So this is the starting term. Then by choosing R equals to 2, my starting term of this would be equals to the starting term of this. But what is the number of terms here? The number of terms is n. So in order for the number of terms in this series to be n, I must take it to be n plus 1, because n plus 1 minus 2 plus 1 will give me just the n terms, just like this. And I also can check the last term. The last term here is 4n. So if I substitute n plus 1 here, I will also get 4n plus 4 minus 4, which I get 4n as well. And if I take n plus 1 inside, this would be n plus 2. And this would for no. So this one n plus 2. Okay, so n, if I substitute, also get n plus 2. Therefore, I know that these two series are exactly equal. If I write out each terms in this series, the two series are exactly equal. So making use, I need to try to make use of this, but r equals to, this is r equals to 2 and this is r equals to 1. But I realized that actually no big deal to add r equals, change it to r equals to 1 n plus 1 4r minus 4 r plus 1 r plus 2 and r plus 3. When I change it to this, I'm actually adding an additional term, the r equals to 1 term. So I need to minus away the r equals to 1 term. But when I substitute r equals to 1 inside, I get 4 minus 4, which is 0. So I know that this, the first term actually doesn't matter. I substitute 1 here, this is a 0. The first term in this series is a 0. So whether I change it to r equals to 1 or r equals to 2 actually means the same thing. That means now I can use this result here, because the only difference, the entire thing is the same. The only difference is n is changed to n plus 1. So I just change all this n to n plus 1 over here. So I'm just making use of the earlier result. So n plus 1 plus 2 is n plus 3 minus 8 over n plus 1 plus 3 is n plus 4. Okay, so I got the result for this part. So the answer for this is 2/3 plus 4 over n plus 3 minus 8 over n plus 4. So this is done, right? Okay, so now that I've done this, I'm going to do the last part, which is part B. I'm going to deduce that this term is smaller than 11 over 156. So I'm trying to find from what they give to me, the question, r minus 1 over r plus 2 cube. Okay, what I know is how do I get to this term, right? Let me think of the way. So this is equals to, if I want to change it to r equals to 1. Okay, let me see. So I'm using the result to the first part. Okay, and I know that this thing is just equals to this thing. Okay, let me think. Okay, using the earlier result, if the earlier result is this, so I recognize that 4r minus 4, this is r minus 1. So I change it something similar. How about this? I know that r equals to 1, 4, then r minus 1, r plus 1, r plus 2, and r plus 3. So I'm taking this is equivalent to this term. I just need to multiply the 4 in, right? So equals to 2/3 plus 4 over n plus 2 minus 8 over n plus 3. That means this r minus 1 is just n over r equals to 1, r minus 1. Sorry, what am I doing? So this is just r minus 1 over r plus 1, r plus 2, and r plus 3. Is I divide both sides by 4, I will get 1 over 6 plus 1 over m plus 2 minus 2 over m plus 3. This is this, okay? So if I want to change it such that it is closer to this thing, right, I need to change to the base to r equals to 11. If I change, that means r equals to 11, r minus 1, r plus 1, r plus 2, and r plus 3. I know that this is equals to, if I want to make use of this result, I need to change it to base the r equals to 1. So I know that, okay, if I change it to r equals to 1, r minus 1, then r plus 1, r plus 2, and r plus 3. I'm including 10 more terms in front. This term has 10 more terms than this. So they are not equal. I have to minus away the first 10 terms, which is r equals to 1 to 10, r minus 1 over r plus 1, r plus 2, and r plus 3. So this way, then this part is equals to this part, okay? So using this, I will say that, okay, this part I need small space, so this thing I'm using the 1 to n is just this result. So I know that this is equals to 1 over 6 plus 1 over m plus 2. This part, okay, just this part is equals to minus then 2 over m plus 3 here. I need to minus away the first 10 terms. So this is the same formula as this, except the n is changed to 10. So that means I will minus away 1 over 6 plus 10 plus 1 over 10 plus 2, so plus 1 over 12. Okay, because of this 10, I'm changing to, then minus 2 over what? 2 over 13. So minus 2 over 13 over here. Okay, so this is my equals to this expression. Okay, so I'll get to, the reason I'm doing this is because I want to make this as close to this term as possible so that I could compare. I could make a comparison between these two. Okay, later you see how I make that comparison. Okay, so 1 over 6 minus 1 over 6, it will just cancel away. So 1 over 12 minus 1 over 13 and multiply by minus. So let's see. So 1 divided by 12 minus 2 divided by 13. Okay, equals to, then put a negative. So change the fraction and put a negative sign in front. So you get me to 11 over 156 plus 1 over m plus 2 minus 2 over m plus 3. So when I see this 11 over 156, I know that I'm quite close to what I want to achieve. So let's leave this here for a moment. This one I need more space, so I'm going to shift it over to this side. So n r equals to 11 r minus 1 over r plus 2 cube. Okay, we know that this term, right, is smaller than this term. I'll show you why I think this term is smaller than this term that I'm writing here. Because you see, I can prove that r plus 2 cube is greater than r plus 1, r plus 2, r plus 3. I must try to prove this. If this is true, that means this term, this denominator is greater than this denominator, which means you dividing by a larger number, you get a smaller number. even that all these numbers are positive. So therefore this is smaller than this series. And this series I have just now, I already had shown that this term is this term and equals to this. So I just need to link to here, so we see that this is equals to this. Okay, right, later. So I would be erasing. So I don't need the workings here. I need the space here, right? So that means this is, I'll just need to make a mark that to show that this is equals to this. And okay, I need to show first, maybe this one, you can prove it yourself. You expand it out and see if there's any way to prove that this part. At least I can show you a few values that for which this is true. For example, 3 plus 2, 5, 5, 5, 25, 25, 100, and 25 greater than, if you take 5 times 5 times 5, so 3. So this is the 3. So this one is 4 times 5 times 6. Is this greater than this? 4, 5, 20, 20 times 6 is just 120. Indeed, okay, this is great. But to prove it, maybe you need more than that. But let's prove it at the end. But for now, we will say that, okay, since this is equals to this, so this is equals to 11 over 156 plus, I want to combine the terms here. So I have m plus 3 minus 2n minus 4. It's just m plus 2 multiplied to minus 2. So I get minus 2m minus 4. And here I will have m plus 2, m plus 3. Okay, so this one will be, to simplify, I will get 11 over 156 plus n minus 2n will give me minus n, and 3 minus 4 will give me minus 1. So okay, so m plus 2, m plus 3. Okay, so what I know is, since now I can erase this because I have already used the results. So now that we can see that this term, this is a negative term because my n is a number that is greater than 1 or greater or equals to 1. I know that this is greater or equals to 1 because 1 is the bottom, n must be greater, to be a upper limit, it must be greater than 1. So since n greater or equals to 1, then this must be a negative number. Similarly, then this bottom must be a positive number. So overall, this entire thing must be a negative number. That means this is 111 over 156 minus plus to add a negative number would be smaller than 11 over 156. So eventually we have proven that this thing is smaller than this thing, and so it will be smaller than 11 over 156. So we have proven that. The only thing that we leave to prove that is that really this r plus 2 cube is always greater than this. Okay, so we will set out to prove this part here. So I will just erase the working here to make space for the working on top. So let's set about proving this. So r plus 2 cube, if I expand it, it will be r cube plus 3r squared times 2 plus, I'm just using the binomial expansion over here. These are the coefficients. So r times 2 square plus 2 cube. That would be my r plus 2 to whole thing to the cube. So this one I'll simplify, r cube plus 6r square plus 4 times 3, 12r plus 8. So on the other hand, we have this one. This is r plus 1, r plus 2 cube. Okay. On the other hand, we have r square plus 3r plus 2 on this side, r square plus 2r plus 1r, so 3r plus 2, okay, on this side, then times r plus 3. This is this side. Okay, so this one when I multiply, I will get r cube plus 3r square plus 2r plus 9r is plus 11r. And okay, maybe I should do it more systematically. Okay, so there's only one r cubed term over here, okay, plus how many r squared terms over here? Plus 3 plus 3, so 6 r squared. 3r squared plus 3r squared, 6r squared. And this seems that for the first two terms they are the same. So then after that, to get the r term, so I get 9r plus 2r, so get 11r. 9r plus 2r, so get 11r. 11r, one less than this, so the last term, the constant term, is just 6. So we can prove that these two terms are equal. So 12r plus 8 is definitely greater than 11r plus 6, because this term is smaller than this. 11r also smaller than 12r. So there's no doubt that r plus 2 cube always greater than this, which is equals to r plus 1, r plus 2, and r plus 3. Therefore, we have proven that just now we are right to say that this term is always smaller than this term. Okay, so that's the proof, and we are done with it.